All right, good morning. Couple of announcements. I am sending out progress reports on Friday. So if you have more than 2 absences, if you're not turning in assignments or getting low test grades, you will get a progress report. It doesn't necessarily mean that you're failing. It's more like a wake-up call, like stop doing this or you could possibly fail. So also, I need you to look at Zangle and make sure that everything is correct. If there's any errors or anything, please let me know. You know, I've been having, as you know, a tough time getting everybody on the same page, do the test on this day, do the assignments on this day. And as a result, it causes problems like errors in my grade book because I'm all over the place. So I'm trying to, things are getting better, but I need you to look at Zangle and make sure your grade's right, make sure that everything looks the way it should. If not, please let me know so I can take a look at it. All right, so here is the last announcement I'm going to make on this. I'm not accepting late work. So even if it's 15 seconds late, I'm not taking it. So once again, on Sunday, I spent over 12 hours looking at various things. And I'm not going to be taking any late work. The assignments are due when they're due, unless there's some extenuating circumstance that you've talked to me about. You're expected to turn in the assignments on time. Okay, here's the other thing. Students on exams are either submitting scratch paper late, which is unacceptable, because I'm giving you 60 minutes to do a 40-minute exam. So, and I'm giving you 15 extra minutes to turn things in. So you cannot turn in your scratch paper even 1 minute late. If you turn in late scratch paper, you will get a 0. And I'm hoping I'm making myself clear. Okay, I'm trying to regulate the exams because you could be sitting next to each other taking an exam. You could be screenshotting things. There's all kinds of things that could be going on. And so I'm trying to control it at some degree. So you can't turn in your scratch paper late. All right. In addition to that, I have some students who are only doing 2 or 3 problems on the scratch paper. That's unacceptable. So here's some advice. Act like you're taking a test in the classroom. If you were taking a test in the classroom, you would be writing the original problem, you would be showing your work and circling your answers. That's what I need on your scratch paper on every single problem. So if I assign 16 problems, I need to see problem number 1 with the original problem in the work, circle your answer. I need to see problem number 2 with the original problem in the work, circle your answer. If you do anything else, it makes me think that you're not legitimately doing the work. So you must do what I'm saying, because the reason why it's taking me so much time is because I'm having to look at the scratch paper, then go into my HRW, then look at the scratch paper. No, I want to see everything on your scratch paper so that I don't spend 12 hours looking at this stuff. So I really hope that I don't have to give you zeros to make my point, but I'm going to give you zeros next time because I'm trying to make my point once again. So I'm giving you one last opportunity. You know, you must submit your scratch paper on time. You must show the original problem, work vertically, and circle your answer. All right, in addition to that, I'd be getting a lot of different excuses, like I can't take the test today, I have to go to a funeral. Well, funerals are made way in advance. So if you need to go to a funeral, you're welcome to take the exam earlier, but you will not take it later. I have a doctor's appointment. Doctor's appointments are set up way in advance. So like I said, you can take the exam earlier, but you can't take it later. So unless there is an emergency, you must take the exam on the day that I say. And if you don't, you will get a 0. All right. So please listen to what I'm saying. If you have any questions about what I'm talking about, let me know, because I am not going to be spending the time I'm spending on these things one more day. I'm not going to. So no late work. You must submit your scratch paper on time for exams, and you must show the work. All right. Now, for those of you who have been doing what I want from the very beginning, you're making it harder on the other students. So I'm just letting you know, when you're doing exactly what I want, you're showing the problems, you're showing the work. I know that my other students are capable of doing that. And so for you guys that are getting 100% or getting in the 80s and 90s, just keep doing what you're doing. And I appreciate that a lot. Thank you for falling in line with what I want. So I appreciate that. And that makes my job a lot easier when you're doing what I want. So I thank you. All right. So today, there is no review for 6.1. There is a review for 6.2, but we're not doing that today. I'm going to teach 6.2. All right, lesson 6.2 is multiplying polynomials. This is California Common Core Standard A-APR.1. So I have talked about this, but I haven't written this on the board. So I'm going to a monomial. Mon means one, like a monologue, and nomial means terms. So this means one term. A binomial, like bicycle, means two. Nomial means terms, so this would be two terms. Trinomial, tri means three, like tricycle. So this would be three terms. So when you multiply, you could have something like this. Couple of things I want to say. First of all, you want to write, see how this is not in standard form? You want to write things in standard form. It will eliminate a lot of issues. The second thing is whenever you have a binomial or a monomial, move it in front. Don't ever put a binomial on the right of a trinomial. If you have a monomial like x, put it in front. And so your first problem in your assignment is going to have an x in it. Make sure you move it to the front. Okay? So, like, let's say you have something like this. You would multiply, you would FOIL the two binomials, and when you're done, distribute the x. Okay, the next thing I want you to know about this is the first step is multiply, which means the variables change. So when you multiply an x times a 4x, remember you add the exponent, so that would be 4x squared. The second step is adding or subtracting, and remember when you're adding and subtracting, you do not change the variable. So for example, if you were multiplying 5x cubed times 2x squared, this would be 10x to the fifth because you add the exponents. If you're adding 5x cubed plus 2x cubed, the answer is 7x cubed. You do not change the variable. and you have to add the same variable to the same power in order to add or subtract. So just remember, the first step is multiplying where the variables change, and the second step is adding where you combine like terms. Now, in your book and in the evaluate, you're going to see them stack the problem, and that's okay. I want you to know how to stack the problem. But the easiest way to do this problem would be to distribute the x to the trinomial, distribute the 2 to the trinomial. So let me show you. So x times 1 is, okay, first thing we want to do is put it in standard form. Okay. So this would be x plus 2, that's a linear factor. And over here, we write this as 2x squared minus 4x plus 1. It will just make things a lot easier if you do that. All right, here we go. So this times this would be a 2x cubed. This times this would be a negative 4x squared. So see how there's a pattern? And that's one of the reasons why this makes it easier. And an x times 1 would be x. When you distribute the 2, you're going to line up the like terms. So this would be 4x squared. This would be negative 8x. And this would be a constant 2. So see how things are lined up? So this would be the final answer, 2x cubed. These are true opposites, so they cancel. A negative and a positive would be a negative 7x plus 2. So that would be your final answer in standard form. So when you have simple polynomial expressions, just do it like this. This will be the easiest way to do it. When you get into the evaluate, they're gonna have you stack things. You should know how to do it both ways. Okay, that's a linear factor, and this is a quadratic trinomial. The first thing you want to do is put them in standard form. This one's okay. This one would be negative 7x squared plus x plus 2. And now we're going to distribute the 3x to the trinomial, and we're going to distribute the negative 4 to the trinomial. So let's do the 3x first. So this times this would be a negative 21x cubed. This would be a positive 3x squared. And this would be a positive 6x. Go to the negative 4. A negative times a negative is a positive 28x squared. I'm lining them up. This would be a negative 4x, and this would be a negative 8. Okay, on the second step, you're going to combine like terms. So this would be a negative 2x cubed. This would be a positive 31x squared. A positive negative depends, positive 2x minus 8. And I'm showing you the easiest way to do this. So those of you who have done the box method, you're not going to like it so much. Those of you who like to stack the problem, you're not going to like that so much either. This is the most efficient and the easiest way to do it. All right, now with that being said, we're going to look at a problem now that involves a bunch of decimals. So it's the same concept, but you're going to see me stack it this time. Okay, can you open up your books to page 285A? 285A. Okay. Read this with me, please. Mr. Silva manages a manufacturing plant from 1990 through 2005. The number of units in thousands can be modeled by n of x. Now notice I'm not writing the entire problem, but I am writing the problem though. The average cost per unit can be modeled by C of x per unit. So it says, where x is the number of years since 1990, it says, write a polynomial t of x that can be used to model Mr. Silva's total manufacturing cost. Now, before we go on, I just want to talk about this real quick. Let's say that there's 26 people in our class. We don't normally call people units, but let's say 26 units of people. Let's say we were going to go to see a movie. Now, I don't know, going to the movies is one of my favorite things. You know, I have a Mickey Mouse blanket. Most of the time, I don't even care what the movie is. I just go for the popcorn. So, yeah. So true confessions here. If I went to go buy us tickets, I would go up to the booth and say, I would like 26 tickets for this movie. Am I going to give them $26? Wouldn't I have to give them 26 times the cost of the movie? Wouldn't I have to give them that much? So what if we're going to a concert? Say we're going to see The Weeknd. When I get on Ticketmaster to buy the concert tickets, it would be not $26. Isn't it 26 times the cost of the ticket? And we want good tickets, so $200 a ticket. So that's what I want you to notice in this problem, is that you have n being the number of units, but don't you have to associate the cost to the unit? So what would be the polynomial then? It'd be the cost, what? Are you guys out there?
Times the unit.
It would be the cost time, I'm sorry, be the number of units times the cost per unit. So that would be your polynomial. Now, I just want to stop there for a minute because this type of thing is really useful in your life, and this is why. So just hold that thought. Let's say that we go to Target, and there's a jacket that we want that's $50. And they tell us that it's 30% off. Do you realize that you can multiply 50 times 0.30, and what do you get? On your calculator, what's 30 times 0.30? So do you realize if you take 50 minus 15, that's what you're going to pay for the jacket? So you're not going to pay $50. With 30% off, you're going to get it for $35. So see how when you get a discount, you subtract from the original price. let's say you want to buy a television that's $300. Let's get a good TV. Let's pay $900. So we're going to get a TV for $90, but there's tax. So let's say the tax is 10%. Well, what you'd have to do is you'd have to take 900 times 0.10. What do you get? What's 900 times 0.10?
90.
So what that means is you're not paying $900 for the TV. You're paying 900 plus 90, which is almost $1,000 more. I'm sorry, $1,000. So you're not paying $900 with tax. You're going to be paying $990. So I want to show you this because I use this stuff all the time. When you do discounts, you always multiply times whatever the price is and subtract it off, always. If you're talking about tax or tip 20% or something like that, you're going to add to the original amount to know what extra you're paying. So I do this all the time. I always pull out my phone. If it says 45% off, I always take whatever I'm buying times 0.45 to find out how much I'm getting off the price. So in this problem that we're doing, we're taking the number of units and multiplying times the cost per unit. And they want us to write a polynomial that represents this. Okay, so here we go. We're going to stack it this time and use a calculator. So we're going to take 0.02 x squared plus 0.2 x plus 3, and I hardly ever use a bar or an x, but we can do it in this problem. We're going to multiply to negative 0.002 x squared minus 0.1 x plus 2. Now, I recommend you use a calculator, but I'm going to do what I can in my head and then use a calculator. So 3 times 2 is 6. 2 times 0.2 is 0.4x. 2 times this would be 0.04 x squared. Go to the next line and put a 0. This times this would be a negative 0.3x. This times this would be 0.02x squared. And this times this would be a 0.002 x cubed. And like I said, you can use a calculator on these. Just don't mess it up. And that would be a negative. Now we put 2 zeros. And this times this would be a negative. So a negative 0.3x. That should be lined up over here. Negative, I'm over here, I'm sorry, this. Lost my place. So this times this would be a negative 0.006 x squared. This times this would be a negative. Don't put the negative in the calculator. Figure out the negative, then multiply. This times this would be a negative 0.0004 x cubed. And the very start would be a negative 0.1234 zeros, 4x to the 4. Try to avoid what I just did. Okay, so you would have your t of x, then make sure you write t of x because they want a polynomial. They don't want a polynomial expression. So they want a polynomial. This would be negative 0.0000. 4x to the fourth minus 0.000 4x cubed plus 0.014x squared plus 0.1x plus 6. And you would say that that polynomial function is the total manufacturing cost where x is number of years since 1990. So, like I said, you saw me stack this problem because it was easier with the decimals to do that, but I showed you two different ways to do these. So. I think I added this wrong. Yeah. This should be point negative. Four zeros, 4x to the fourth. And this should be minus point, this one right here is messed up. This should be 0.0024x cubed, because you have to line up the decimals, plus 0.014x squared, plus 0.1x plus 6. That's right. So right here, these decimals have to be lined up. So it ends up being a negative, negative is a negative, and you add negative 0.0024x cubed. So anyhow, it's not hard, it's just tedious. All right, any questions? Okay. The next thing I want to look at is something called a polynomial identity. So a polynomial identity is a mathematical relationship equating one polynomial quantity to another. So they're going to ask you to verify. And you don't do this so much in Algebra 2, but you verify all the time in pre-calculus. And verify means prove. So this is a proof. So what they're going to do is they're going to give you an equation. And they're going to want you to prove that this is true. Writing on a slant, huh? So some students have asked me, well, what if it's not true? Well, it's true. So every statement that you verify is true, They just want you to prove that it's true. So a couple of notes. The first thing is you want to work with the more complicated side. The second thing is don't move things across the equality. Keep the left side on the left and the right side on the right. So don't ever move anything across the equality. All right, so here we go. This is the simple side. So we're just going to leave the 4ax, and sometimes you can use like quotes so you don't have to write it over and over again. You're going to write it at the end, but you can write quotes like that. That means 4ax. So on the left, we're going to multiply this out. So this is x plus a times x plus a minus x minus a times x minus a. So once again, the right side is just 4ax, and we're going to FOIL. So this would be x squared, outer would be ax, put the monomials in alphabetical order, a before x, plus ax plus a squared minus, and make sure you put this in parentheses so you don't fail to distribute the negative. This would be x squared, outer would be negative ax, inner would be negative ax plus a squared. So combine like terms. So this would be x squared, and 1ax plus 1ax is 2ax plus a squared minus, this is still in parentheses, x squared, and a negative is a negative. 1 plus 1 is negative 2ax plus a squared equals that. Distribute the negative. So that would be negative x squared plus 2ax minus a squared. So x squared and negative x squared disappear, a squared and negative a squared disappear, and you get 2 plus 2 is 4ax equals 4ax, and you put a check because you proved it true. Now, like I was telling my pre-calculus class, you know, there are programs out there that I know you're aware of where it does the problem for you. There's apps, you know, that you write the problem and does it for you. I do think that a lot of my pre-cal students are doing that, and they're just totally blowing the test grade. And that's why they're not able to show the problems on their exam paper, scratch paper. But make sure you're legitimately doing work. You don't want to put yourself too far behind. So this is a verified, this is a proof. Let's do another one.
Birch, what does stars say on the side?
Yeah, this says work with the more complicated side. So in other words, change the more complicated side. And in this case, the left side, there was nothing to do on the right side, so I worked with the left side. In this problem that I just wrote on the board, the more complicated side is the right side, because there's nothing to do on the left side.
Miss.
And then this, hold on, this says keep the left on the left and the right on the right, which means don't be adding or subtracting anything across the equal sign. Okay, go ahead. What?
Could you read the word that's underlined under polynomial identity?
Okay, it says a mathematical relationship equating.
Okay.
Sorry. One polynomial quantity to another. Sorry. Okay, so over here, the more complicated side is that side, so I'm just going to carry that guy down, and we're going to FOIL first, outer, put the monomials in alphabetical order, minus a squared. Those cancel, and you get x squared minus a squared equals x squared minus a squared. So that was pretty easy, a lot easier than the other one. So basically, you're just making one side look like the other. Okay, do you guys want to ask me any questions about verifying? Okay, I don't know how many of you looked at the assignment, but I skipped a bunch of problems in the assignment. So if you look at the assignment, I'm having you skip 16 through 21. So there's 6 problems that I don't want you to do. And it has to do with evaluating, and I don't know. To me, it seems pointless, and they're supposed to be showing you this to make things easier, but it doesn't. So we're not going to do it. So we're skipping 16 through 21. As a result, when we do the review for 6.2, I added practice AB to compensate for it so you could practice. But make sure also in the evaluate online that you do not do problems 16 through 21. And I don't have them in the assignment if you look on Google Classroom. All right, that is the lesson. And we are ready for an exam after we do some practicing. The exam will be 6162, and that will be on Tuesday morning at 8. So it'll be a week from today at 8 o'clock in the morning. But we got a lot more practicing to do. We haven't even done the review yet for 6.2. So what we're going to do today is we're going to go into the Math Wizard teams, and you're just going to start on the assignment. Now, here's the deal. When you're working with your teams, you have to decide, are we going to stack it or are we going to write it out horizontally? Because you can't work together if 2 people do it one way and 2 people do it the other way. So you have to decide, are you going to write it side by side, like I suggested? And then when you have decimals, stack it, because you have to check your steps, because these problems are really long, and you don't want to say the answer and everybody have different answers. So, all right, it's about 11:30. It's close to it, and class is over at 12:10. We're not going to come back here. If you have questions, you can ask me or send me a message, and we're going to work on lesson 6.2. All right, I'll see you in your teams. I am going to change the teams in the near future, but we're in the same teams today. So I'll see you in your teams working on lesson 6.2.